Okay, so now we'll be discussing about the first type of chemical reaction, which is a combination reaction. We have already seen a brief summary of all the types of reaction. So we already know that in combination reaction, two or more substances reacts or combines to form a single product. So let us write down this formal definition of combination reaction first. So a reaction in which two or more more substances, these substances can be either element or compound, can be element or compound. So a reaction in which two or more substances combine to form a single product. A single product is called combination reaction. It's called combination reaction. So basically, two or more substances, let us say A and B, it can be more than two also, they combine together and form a single new product, which is AB. Now we'll see a practical example of a combination reaction. For this, you will have to take water in a beaker or a jar. Take some water, put few pieces of calcium oxide in this beaker. So few pieces of calcium oxide. So let's say you have, these are calcium oxide. Calcium oxide is CaO. So what is happening over here is calcium oxide, it reacts or combines with water and it forms a single product, which is calcium hydroxide, CaOH, SOH twice. So OH is written in bracket. You already know how to write these formulae using valency of cations and anions. So what is happening in this reaction is two reactants, they are combining together to form a single product. Also, you can observe increase in temperature in this reaction by putting a thermometer in this reaction mixture. So lots of energy in the form of heat is evolved in this reaction. So heat is not considered as product because it is an energy. So our product is only calcium hydroxide. So it is an example of combination reaction where calcium oxide combines with hydrogen to form calcium hydroxide. Calcium oxide is also known by another name, and these names are very important. You must remember these names also. It is called quicklime. Calcium hydroxide is known by name slaked lime. Slaked. So these names are important. Remember it. This is completely soluble in water. So what you will get over here is solution of calcium hydroxide in water, because water is already there in the medium in excess. So its solution is clear solution. It is completely soluble in water and it makes clear solution. You can see that few ingredients are combining together to form a single product. So it looks like something is getting synthesized in this reaction using a few ingredients, and hence combination reaction is also known by another name. It is uh, so its other name is synthesis reaction. Synthesis reaction, or I should write it here only. It is also known as synthesis reaction. Combination reaction or synthesis reaction, both are same thing. Okay. If you are doing this experiment in lab, you should keep in mind that calcium oxide is very corrosive, so you must wear proper gloves and lab coat to avoid burning or irritation of skin. Okay. Now this solution, which is calcium hydroxide in water, has very important role to play. So now we are going to see a very important function of calcium hydroxide, though this topic may not be relevant for the upcoming topic may not be relevant for the board examinations, but if you are preparing for any competitive exam, so you should know this. So this is an important concept. This solution of slaked lime is used for whitewashing walls. Though nowadays we have got different paints, wall paints, but a few years back, I think maybe 15, 20 years back, when these paints were not available, only that at that time only slaked lime was used to whitewash walls. Now, what happens is we already know that this solution is, the slaked lime is completely soluble in water, and hence this is a clear solution. It is a transparent solution. Then why it is used for whitewashing? What happens is this calcium hydroxide, when reacts with carbon dioxide, and carbon dioxide is already present in our atmosphere, it forms calcium carbonate. Calcium carbonate is a very hard substance. It is white in color. It is hard and shiny, white in color, along with water. So when this solution is applied on wall, calcium hydroxide present in the solution starts reacting with carbon dioxide present in atmosphere, and slowly this gets converted into calcium carbonate, which is white in color, very shiny. However, this reaction takes 2 or 3 days to complete, and hence the proper color on wall, if slaked lime solution is used, then the proper white color of the wall appears after 2-3 days. Calcium carbonate is the substance with which marbles are made up of. Marbles are basically calcium carbonate, and eggshell chalk, they all are calcium carbonate. These marbles, they are also known as limestone. Must have heard of this name, limestone, made up of calcium carbonate. So this is important information that you should know for your competitive examination. We must also know another important thing about calcium hydroxide is saturated solution, saturated solution of calcium hydroxide in water is called lime water. This is called lime water. So these names are very important. What is lime water? It is saturated solution of calcium hydroxide in water. And what is saturated solution? You have studied it in your previous class only. Saturated solution, it is a solution in which solute is added in so much of quantity that it no longer dissolves in water. So it dissolves in water completely, and any excess amount of solute will not dissolve in water. So it is very, you can say, very concentrated solution of or highly concentrated solution of calcium hydroxide in water is lime water. Now, why I am telling you about lime water? So it is used to uh, test carbon dioxide gas. For example, you take lime water in a test tube, and if you want to test, so this is, let us say, this is lime water, and if you want to test any gas which is evolving from any given reaction, if you want to test, or if you want to confirm that the gas which is evolving is carbon dioxide, then what we will do is we will pass that gas from lime water. Now, carbon dioxide, so lime water is basically calcium hydroxide in water, lots of calcium hydroxide in water. And calcium hydroxide is completely soluble in water, therefore the lime water is a clear solution, a transparent solution. When, when calcium hydroxide reacts with carbon dioxide, what happens is it forms calcium carbonate. It is white in color and insoluble in water, and hence it makes lime water milky. So these small particles of white colored calcium carbonate will be distributed in this solution, and it will make the whole thing milky. So on passing carbon dioxide through lime water, it turns lime water milky. So calcium carbonate makes lime water milky. And if you continue passing carbon dioxide for few more minutes, then what will happen? With excess carbon dioxide, this milkiness disappear because calcium carbonate in water then reacts with carbon dioxide and forms calcium hydrogen carbonate. So go to next slide. So when we continue passing carbon dioxide in that solution, then calcium carbonate, and this solution is already there, and with excess of carbon dioxide, this CaCO3 gets converted, or all CaCO3 will be converted into calcium hydrogen carbonate, right? And this is again soluble in water, soluble in water. So it will dissolve completely in water, and milkiness, which was due to calcium carbonate, will disappear. So up to this point, starting from here, so starting from this point to this is will not be asked in board examination, but it is important if you can remember these things because they are very much relevant for your competitive examinations. Okay, now moving on, let us discuss some more examples. Combination reaction. What is its other name? Synthesis reaction. Combination reaction or synthesis reaction. Let us see some more examples. So the first is burning of coal. Burning of coal. Coal is a type of combination reaction. Again, burning. So that means something is reacting with or combining with oxygen. And here coal is combining with oxygen. What is coal? It is basically pure form of carbon. So coal means carbon only. Carbon is in solid state. It reacts with oxygen, O2. It is gas and it forms carbon dioxide. Again, it is gas. So you see, two reactants, they are combining together to form a single product, and hence this reaction will be a combination reaction, right? We have one more example. In fact, there are several examples of combination reaction. We will see a few more examples. So the second example is a formation of water. Formation of water. Okay. Before going into this example, let us see whether the above equation is balanced or not. One carbon here, one carbon here, two atoms of oxygen, two atoms of oxygen. So yes, it is balanced. Now let us talk about formation of water. What is water? It is H2O. So it needs two things: hydrogen gas H2 plus oxygen gas, which is O2. They will combine to form water. What is water? So here you see two reactants which are in gaseous state. They are combining together and somehow their state is changed to liquid. Right. So water is liquid. Now let us see whether the equation is balanced or not. Two hydrogen, two hydrogen. So it is hydrogen atom is balanced. Two oxygen this side, one oxygen this side. This is not balanced. So in order to balance it, we need two oxygen this side. But as soon as we will put two here, so hydrogen atom will become four. So to balance the hydrogen atoms, should put two here. So now four hydrogen, two oxygen, and two oxygen, right? Now this is balanced. So what is happening in combination reaction? Two substances are combining to form a single product. Let us see one or two more examples. Formation of ammonia. Ammonia is gas and it has several industrial importance or industrial uses. NH3. Ammonia is NH3. It is a gas. So it needs nitrogen and hydrogen. So nitrogen is a gas. When reacts with hydrogen gas, it forms a single product called ammonia, NH3. And you can see that it is not a balanced chemical equation and you need to balance it. So two hydrogen this side, three hydrogen this side. So it is not balanced. One here, two nitrogen this side, one nitrogen this side. Again, not balanced. So in order to balance, what we are going to do is we are first going to identify that compound which has maximum number of atoms. So NH3 is the compound which has four atoms. So we will try to balance NH3 first. So one nitrogen here, two nitrogen here. So if I write two here, it will be nitrogen will be balanced, but hydrogen won't be balanced, right? So, okay, first of all, let us write 2 here. So this balances nitrogen. What about hydrogen? So it makes 6 hydrogen atom. And here we have only 2 hydrogen. Now in order to balance hydrogen, what we can do is we can write 3 here. So 6 hydrogen this side, 6 hydrogen this side. 2 nitrogen, 2 nitrogen. Now it is balanced. So balancing, you now you already know that I'm just showing you through this example. It's a kind of revision of balancing exercise. So these are few examples of combination reaction where two or more reactants they combine to form single product. Now most of combination reaction, let me write it here itself. This is very important. Most of these reactions, these combination reactions, are exothermic in nature. Exothermic in nature. Now, what is exothermic reaction exactly? That means in most of these reactions, heat is evolved, right? So we have already seen our very first example where calcium oxide reacts with water to form calcium hydroxide with the liberation of heat. Similarly, in burning reaction also lots of heat is evolved. During formation of water, lots of heat is evolved. Even in the formation of ammonia, lots of heat is evolved. So all these reactions are exothermic. So the reactions that we have seen so far, they all are in fact exothermic. But there are a few exceptions also. There are few reactions which are not exothermic, few combination reactions which are not exothermic. And that is why I am writing it like this. Most of the combination reactions are exothermic in nature. That means heat is evolved in these reactions. I should give you one example of combination reaction which is not exothermic. So one such example is formation of carbon disulfide CS2. This is endothermic. That means heat is absorbed in this case. So carbon reacts with sulfur to form CS2, right? So carbon is solid, sulfur is also solid, and CS2 is liquid. So this is an example of endothermic reaction. But anyways, most of the combination reactions they are exothermic in nature, and we will talk about exothermic reaction in the next lecture. We will see what is exothermic reaction. I will give you a formal definition also, and I'll give you a few more examples of exothermic reaction, which may not be a combination reaction, but we will see few examples of exothermic reactions. First, second, and third examples are also example of exothermic reaction, but these are specific to combination reaction. We will see few more examples of exothermic reaction.